This first video is going to cover the core Rhino information on the component and integration of Python, and move a little further and just cover the initial bases. So we'll go over the component, the editor, an initial script, and the syntax real quick, and then the use of Python itself I think is important to hit on this first one. So this is the documentation for Python. I'll have links to all of these pages. So the Python documentation is for 2.7, and current Python is in Python 3, but the version that Rhino uses is a 2.7, and it's the same for Windows and Mac. There's also a series of lecture videos from MIT that is Intro to Computer Science, and it's all done in Python. So it's a really great way to get more familiar with Python with a more accessible format. So you can reference quick specific stuff here, such as Boolean operations, numeric types is a good one. But as you can see, these can get pretty lengthy and verbose, so we'll try to keep it to a minimum of the use within, again, the Python component. And if you ever want to get more involved or deep into Python, I do think these MIT lectures are a great way to get started with that. So let's go ahead and move forward. Okay, in our Grasshopper environment, if you are looking at the tabs up top, you'll notice the second from the left is the Math tab, and in the script group you'll see these two little snakes hanging out together, and that is the Python component. Drag that onto the canvas, and you'll notice if you zoom into the component, it has these little pluses and minuses on the input and output side. And what those are ways to add variables and subtract them. The inputs will add in up to Z and then back down, and the outputs will start at A at the bottom, or the start of the alphabet. And we can customize these, and we're going to see how to do that. And in the code, these are the variables that are referenced. Whatever is named here is what is referenced in the Python code. And if we double click the component, the editor will open up, and we'll notice that in the editor you'll have the output and help for any functions and stuff we're referencing on the bottom, and you actually write the code up top. And so, ignoring this information right now, we're just going to look at referencing these variables. And I'm going to go ahead and add one. So we have 3 variables on the left and an output variable. So I'm just going to create variables in the code that reference these variables. I could just as easily go area equals x times y. But if I do that, then x times y is sort of not explicit, and it's hard to understand what that might be if things change. So what we would typically do in code is go ahead and give that a variable reference. So since I want something clear, I'm going to go in that is explicit. I'm going to go height equals x equals y, and length equals z. And so now when we go to make area, we do length times width. And that is a lot easier to read, and anyone else can come to your code, and you can go back to your code and you can know exactly what you meant and what variable was meant to do what, because you're referencing up here and being explicit. So now if we have the area, there's no way to see this. We don't have any variable for an output. So to get this to actually read on an output, we would have to then say A equals area. And that is how we would read the information that the area variable has gained from multiplying the length and the width variable that took information from the z and the y input variable from the input. So this can get sort of convoluted, and right now if we go to A, we're just going to see null. And if we go ahead and test the script up here, you'll notice that now we even get an error, and you have to test the script first for it to run. So if we hadn't tested the script, we wouldn't even be getting the error. We just get null. And so right now we don't have any inputs, so we're not giving it any information. So you're seeing none type here in the bottom, this output. So we ran the test. Now it's giving us an output of the code that was in our editor. And so since we don't have any types to send to it, it doesn't know what we're asking it to do. And so if we just plug in a little slider, you'll notice it goes away, and then voila, we're getting an output over here. And so we can grab ourselves a little text panel, drag our output into it, and then see on the fly that we're getting our data to change. And so that is our first functioning Python component, just to get some area. And we go ahead and take this little slider and make it a little more architectural in size, and give it a ceiling of 1,000 and a minimum of, say, 10. And then we'll go ahead and copy and paste 3 of these so we have independent data. So you'll notice their floating point. We have this floating point coming out, and we'll talk about that in just a second, about our typing on the inputs. And so back to the variables and the typing, as we come into the variables in Python, if you again right click on them, you'll notice that we have access to the name, so we can name these variables ourselves. But if I were to name this say ZZ, and then try to run this again, I'm going to get an error because the length is referencing up here in our code, it's referencing Z. Z doesn't exist anymore. Z is now ZZ. And so if we added the Z, now we're referencing ZZ, and we go up and click test, it works again. And so your variable here is what is referenced in your code. And now, knowing that, and knowing that we can click this and edit our variables ourselves, well, we can take a step out, and this is one thing that's really lovely about the Python component, is as we start building out our component, we can be explicit in the way the component is visualized and utilized. And what I mean by that is we can go ahead and call this just length. And we can call this width. And we can call this height. And now in our code, we don't have to reference any of these. We've now gotten rid of that. But the variable is still the same. We're referencing length, we're referencing width, and we have an area. And so if we scrub length and width, we should have it changing. Oh, it's not changing though. That's because we haven't tested it yet. And now, as we scrub it, you can see it change. So whenever you make the change in the code, you have to run a test. For instance, if I called this, just some random name that doesn't reference area, it should throw an error. It hasn't thrown an error yet. If I go test it, there's the error. No data was collected because it didn't reference anything that actually had data associated with it. I go type area again and I test that, and we're getting the right information. And so The next part of these inputs and the variables that we can look at if we right click again, and so up top we can define our own variable name, and that is what the input name is, what it is referenced in the code. But another thing we can do, Python is what's called loosely typed, so it doesn't always, it doesn't ask for you to be explicit on what type of information you're feeding it. But within Rhino, we have these type hints at the bottom. And this is a way to let the script know beforehand what this information is that you're passing it. And why this is important is because you're not leaving it up to Python to figure it out and parse it. So as far as like figuring out your code, if there's an error, you can know exactly why. It'll throw an error. And for instance, if I say this is a string on length, I just got an error. It's looking for a type float. So we're doing this multiplication. The variable length right here wants to be multiplied. Python's trying to do that. And so Python would typically attempt to, like it is, it's loosely typed. But by, oh, sorry about that. Oh, come on, help. By type handing to float, it works again immediately. We didn't even have to test that. And so floating point is what the information coming in is. And so here we don't have a type hint for it, and we're just letting Python figure it out, which in many circumstances is fine. But there's probably a circumstance that you might want to make sure on the input side that whatever information that is coming into Python is something you've defined and is expected. That way you can know why an error has happened within your code itself. Okay, so moving forward from here, we can do the same thing on the right side. So we can take this and call it area. And now we can get rid of this A. And so now we just made a little Python component that allows us to define area from length, width, and height. Sorry about that. And so now we can look at something within the code itself real quick. And so Python is based on libraries, or it works with libraries. And you'll notice this import, that's the import of the full rhinoscript syntax library, which I referenced earlier right here. And again, I'll have links to this below the video. And so this is all the rhinoscript syntax that the Python component has access to. And it sort of shows the power of what a single component can do versus the individual little components that Grasshopper is primarily made out of. And so by importing this, we've imported that library. All of that information that I just looked at now is accessible with just the word rs, or excuse me, the letters. And if I go rs dot, then the next step I have is the action from that library. And these are the actions that you have. So by importing the rhinoscript syntax right here as rs, now I can reference that whole library through just the letters rs. And by doing a prefix as rs and then dot, the next is the actual action function or reference itself. We have references to planes, we have actions, we have all sorts of functionality within here that you have a reference to. Now Python itself has its own libraries as well, so it can get pretty exhausting. There's a ton of magic that you have access to. And so for instance, in Python I can import a random library, and you'll notice here it doesn't come up as an auto access reference. So there are even Python libraries that still aren't in the highlighting. You can get more familiar with those in the actual documentation. But again, this is sometimes a rabbit hole. But if there's a specific one that you know about and it's not in there, you can get more, or you can get more information on one that is in there. For instance, if you do math, sometimes actually if your hints aren't coming up, you can go back and like add a T space and then they'll come back. So just go back a few spaces. And then you'll notice if you start typing, then it'll just fill in the hint path. So import math. And now in the code, I can go math dot, and you'll see all the functionality that follows. And this is all of Python's mathematic programmatic functionality. So and if you go into the help, you'll notice that as soon as you do your parentheses is how the function is called here, down in the help it tells you what the actual code looks like that would call that function. And so that's importing Python libraries, importing the Python rhinoscript syntax library. And so you'll notice this as rs is basically a shorthand of how you can reference the whole library. So we could say import math as cat. And then if I came down, it'd be cat dot and all the same stuff. So now math would be referenced as cat. And so trying to understand the variables and the libraries and how they interact with, again, can be sort of intimidating, but it's pretty basic stuff. And so now we've set the variables. They're actually in the component. We are referencing an action here, just a simple mathematical multiplication, active multiplication, using our variable that is set on the output. And so it's a really simple component that's all self-contained with variables that are self-referenced that I can see up here and immediately get an idea of what this is, instead of having to have multiple components. For instance, then we have to have an A and a B, but I don't know what these are. I don't get to know height, width, and if the variables were to change or anything else were to change. Now this is just 2. If I start wanting to have volume, then I start having to have more complex organization of components. And so why I find the Python component so useful is it is self-contained, and so it can be very explicit, it can be very customized, and it can be very useful in whatever application you can find for it. And so lastly, one last thing is, we have this floating point going on here with our area, and if we wanted those to be integers, there's a few ways we could do it. Notice here, we change these sliders to integers. We're still getting floating point. And then you can change the actual variables, their type hint. Right now we're letting Python figure it out, and we could also go to float, or we could go and say, no, these are integers that we expect on both of them. And so now they are seen as integers, but the scrubbers are too, so we can take the scrubbers back to being floating point. And you'll notice that our answer is still an integer because the Python inputs that we're using explicitly are set as an integer. So we're only getting 509 and 575 here. Now we could also leave those as up to Python and back at floating point again, but inside the code we're going to use int and then wrap our math in some parentheses, and so this is going to take this multiplication, length times width, and turn it into an integer. So now if we test, it's an integer as well. So those are just a few different ways to change that floating point to an integer from either the input variable itself, right click type hint, so either through a type hint or in the code itself to the output variable. So you can do it either way, through the input variable or output variable. Well, I think that's enough to chew on today. Thanks for going through all this, and hopefully this is of some value, and if so, then I'll be bringing some more to you. Thank you. Take care. Bye.